Okay, we're going to solve a system here by using triangular form. First of all, I guess we should talk just a tiny bit about what triangular form is. We want to convert our system here so that the first equation on the top has x's, y's, and z's, where the coefficient on x is a 1. The second one we want to write where it's just got y and z, and the coefficient on y is 1. And then this one we want to write the third one where we only have a z in there, and the coefficient is 1. The definition 8.3, where it talks about, or it defines what triangular form is, that's on page 556 of the textbook. But that's essentially what we're going to do. We want to write the system so that we have in the first equation x's, y's, and z's. The second one we only want y and z, and then the third one we only want z. One of the theorems, hope that fits, good. So these are the things that we can do. We can interchange any two equations, so I can just flip their places. We can replace an equation with a multiple of itself, so I can multiply everything in the equation on both sides by the same number and replace that equation with that. Or we can kind of do a combination of these things. We can replace an equation with itself plus a non-zero multiple of another equation. So I can take an equation and add a non-zero multiple of another equation. So let's do that. So our big goal here is to be organized here. I don't know, these problems have a whole lot of ducks in a row kind of feel to them, and if we make one little error, the whole thing's going to get off base. But at the very end, when we get to the finish, we can go back to the original system and we can just check our solution really quickly. So let's get rolling here. So we want to write this in triangular form first. So I want to have a 1 here. That's my first step. I want to have an x and a 1 in that first equation. Well, we want to make things as much as we can. We want to make things just as easy as possible. So I think the easiest thing that we could do to make it so this equation, or excuse me, this system has an x on the top with a coefficient, I think the easiest thing is just going to be to interchange our row 1 and our row 2, or excuse me, row 3. So if I take row 1 here and interchange it with row 3, that's all we're going to do. And that's all we're going to do. So we can do that. We've got in the top now x plus z equal 8. The second row did not change. We got 3y plus 9z equals 63. Okay, and then the bottom, these are what we're flipping around. So this one's going to get switched with this one. So I got 4x minus y plus z equals 7. All right, so there's our new system there. Great, so now I've got a 1 there, and we're kind of on our way to getting it done. So now what? We want to, this is good. I've got a 1 in front of my x. Now on this one, I want to have a 1 in front of my y. So here I can see pretty quickly, these are all multiples of 3. So it would be pretty easy for us to just take row 2 and divide it by 3. And I'm going to put that in place of row 3. So if we do that, everything else is going to, I meant row 2, excuse me, row 2. Yeah, right, organization is important, and well, good thing we caught that. All right, so we're taking 1/3 times row 2, and I'm going to put that in place of row 2. Nothing else is going to change. I'm going to leave this one, I'm going to leave this one. I'm just changing row 2, so x plus z equals 8. And then this one, we're taking 1/3 of that, so that's y plus, and then 9 divided by 3, that's 3. And then we've got 63 divided by 3, what is that, 21? Okay, and then this one didn't change. I got 4x minus y plus z equal 7. Okay, so now this row is good, right? I've got an x, my coefficient is 1. I've got a y, my coefficient is 1. There is no x, so that's good. Now in this one, I just want to eliminate my x term and I want to eliminate my y term, and then we're finished. So we can take now multiples of this one to get rid of that x. So if I take and I combine, I'm going to take row 3, and I'm going to subtract off 4 times row 1. Excuse me. So we're going to take 4 times row 1, and we're going to take that away from row 3, and I'm going to put that back in place of row 3. So rows 1 and 2, those aren't changing. Those are good. We've got a good thing going on in rows 1 and 2. Okay, and now I'm going to take row 3. I'm going to subtract off 4 times row 1. So I've got row 3 is here. I'm going to subtract off 4 times row 1. So I've got 4x minus 4 times x, so that's 0. And then I've got negative y minus the y term. Well, there isn't a y term here, so I'm not subtracting anything from that. I've just got a negative y there. Okay, and then we move to the z term, so I got z minus 4 times z, right? We're doing row 3 minus 4 times row 1. So every variable position, we're just subtracting off the, its counterpart in the first row. So we've got, right, there wasn't anything to subtract from the y, so we got z minus 4z, so that's going to be minus 3z. Okay, and now this looks like that might be trouble. So, well, we'll see if it's trouble. We want to keep going here. So I got my z term, and then we've got 7 minus 4 times 21. So 7 minus 4 times 8 is what I wanted to do. So 7 minus 4 times 8, that's 7 minus 32, which should be what, 25? Okay. And then we do the next step, right? So we would want to eliminate this y, but we can kind of see that's going to give us something goofy. So we can take and add these together, because that's going to eliminate our y. So I'm going to take row 2 plus row 3 and put that in place of row 3. Okay, so then we've got x plus z equal 8, y plus 3z equal 21. And then this one, if I add together row 3 plus row 2, those guys cancel out, those guys cancel out, and these leave us with a negative 4. So that is, whoops, off the screen there. So that is the triangular form, but the triangular form shows us that we have a contradiction there. So what that tells us, this tells us, is that we have no solution. There's no situation where that's going to be true. So we would conclude no solution. I think after I wrote this, I realized that we should be writing inconsistent, right? We say it's inconsistent when there is no solution. All right, wonderful. So yeah, triangular form is really useful here, right? Because it immediately either tells us that we have no solution, or it's going to be a really quick roadmap to the solution, right? If I would have had this one with z and a 1 for a coefficient, I would just immediately know that z is negative 4, and then we can just do back substitution for both y and z and find the solution really, really quickly. But again, in this case, we came to the conclusion that this was inconsistent because we had a contradiction come up there. So wonderful.